Welcome to Panel 1, Panel 2 and my supervisor. I'm from Faculty of Mechanical and Manufacturing Engineering Technology. Today I'm going to present on my Bachelor Degree Project 2. The title of my project is Design of a Restroom Exhaust Ventilation System Sensor for Odor Elimination. My name is Kuganeswarao like SUBRAMANIAM. My matrix number is B0918104887 and I'm from 4 BMMH 1/2. The content of this slide is introduction, which will be discussing on the definition of ventilation. Next one is problem statement, research objective, which is divided into two: general objective and specific objective, scope of study, literature review, methodology. Methodology part, there is few parts: components and materials, project development, software development, block diagram, prototype design, project working principle, and flowing by results and also limitation and conclusion. Next, we are going to see on the problem statement. Odor is the main problem in the restroom because most of the place does not have a good ventilation. Strong odor in a restroom can lead a person to be in health problem, mainly for the pregnant woman. Not only a pregnant woman, the elderly also might be affected. A lot of unwanted gas in the restroom, for example, ammonia and carbon dioxide. The last problem statement is the tobacco smell in the restroom. And now we are going to see on the research objective. The general objective of this project is to eliminate odor in restroom using low-cost sensor. The specific objective is to identify the odor parameters such as carbon dioxide and ammonia in the restroom prototype, to compare the level of carbon dioxide and ammonia, to develop the low-cost fan system by using Arduino Uno as platform to tackle the odor. The scope of the study is to use the sensor to detect carbon dioxide and ammonia. Arduino should be used as the controller. Exhaust fan only need to operate when needed. It will be in the standby mode if there is no need to operate. Now we are going to see on the literature review part. The main title is the ventilation. To keep occupants healthy, buildings are vented to get outside air into a building or space and disperse it throughout it. This statement was stated by Nelson and Lee in 2019. Ventilation system must be implemented in highly insulated and airtight buildings. This statement was stated by Mason-Holler, Veneman and Husong in 2020. The next one is the odor. Odor can influence emotion and mood. 5 minutes of exposure to an unpleasant odor might cause a negative mood and mild anxiety, whereas 5 minutes of exposure to a nice odor can provide a positive mood and relaxing effect. This statement was stated by Contreras, East and Wilson on a journal which is written in 2020. The most major source of air pollution is the odor. This statement was stated by Bokowa on 2021. The next title is odor sensor. Many industries, including food and environment, health and perfumery, require an odor sensing device. This statement was stated by Mugino on 2017. And now we are going to see on the methodology part. The first component is Arduino Uno. It is used to receive signal from the air quality sensor. When the sensor detects smell, the Arduino transmits signal to the output. The next one is air quality sensor MQ135, device that detects surrounding air quality. Next one is PC fan, which works as the exhaust fan to extract the odor. The list of material is 20 mm thick furniture plywood to be used as the surround wall, roof and the door of the prototype. Now we are going to see on the project development. At first, I gathered information about this project and I have done with the hardware, at the same time with the software also. After I've done with the hardware, I reveal the hardware by test the hardware whether it's working correctly or not, and if there is some defect, I troubleshoot and the hardware is being tested again to, to produce the final design. And when we see the software development, I also reveal on this software. If there is some error, I have debugged and the software has been generated until the final design can be operated. This is the software development part. Once the sensor is working, the system will be start. The sensor send ppm reading to the Arduino. If the ppm reading shows more than 10 ppm, the PC fan will be turned on, and if it is less than 10 ppm, the system will be going up again and will need input from the sensor. And once the PC fan is turned on and the order is released, it will be rotating. The system will be rotating and functioning as well. This is the block diagram of my project. The Arduino Uno is occupied with the input DC power supply, air quality sensor MQ135, and the output of this project is the exhaust fan. And right here there's a circuit diagram. This is how I connect my wiring from the Arduino to the sensor and also to the relay to be used for the exhaust fan. I mean the PC fan as the exhaust fan. This is the prototype design I've drawn in the SolidWorks, which the length is 26 cm, the height is 40 cm, and the width is 28 cm. I've built this prototype accordingly. And now I'm going to explain on how the project will be working. At first, when the system is powered, the PC fan and also the sensor will be in standby mode. And once the ppm value increases in the partition, the exhaust fan, which is fixed as the PC fan, will be start running to extract the unwanted gas in the partition. Right now I'm going to explain on how the carbon dioxide and ammonia gas I released in the partition. According to the carbon dioxide, we can be produce carbon dioxide by burning a paper in the partition, and I have did that in my partition to get the value and the results for my experiment. And the ammonia gas releasing, I have used a cow urine for the ammonia gas producing. I have boiled the cow urine for the ammonia smell to be released in the partition, so that I can get the best results for the ammonia reading. And now we are going to discuss about the results. This chart describes on the carbon dioxide chart without fan. That means I've got these results without the PC fan running. Once the carbon dioxide is released in the partition, the ppm value will be keep on increasing, and as you can see over here, this part is has been decreased because of the burning has been stopped, and I have managed to notice that. And once I have burned the paper, the reading has been increasing, and this result was was produced without the fan. And now we are going to see on the carbon dioxide chart with the PC fan. Once there is a PC fan activated in the partition, when the carbon dioxide gas released in the partition, it when reach the more than 10 ppm value, the PC fan will be activated and the ppm value will be dropped and will be increased. Once the ppm value is dropped, the PC fan is stopped, so the ppm value will be increased again, as you can see here. Once the ppm value is more than 10, the fan will be activated and the order will be extracted from the partition, and the cycle repeats. I do this experiment for 2 hours to get these results. Right now we are going to see on the ammonia chart without PC. When I release the ammonia gas in the partition, the reading is keep on increasing and increasing, and it reaches until 40 ppm. Compared to the carbon dioxide, ammonia is very higher gas releasing. As we can see in this chart, the the ammonia gas in the partition keep on increasing and it never exceed more than 40. And now we are going to see on the ammonia chart with PC fan. Once the ammonia gas is released in the partition, I've got the chart on like this way. This chart can be explained further. Once the ppm value increase, the exhaust fan will be turned on and the graph will be going down, but then not as carbon dioxide. The off interval for ammonia is very short because ammonia gas does not release easily in the partition, so that the off condition and on condition compared to the carbon dioxide is slightly different. As we can know, ammonia's turning on time is very quite long a bit, and then the turn off time is shorter compared to the carbon dioxide. During completion of my project, I faced some of the limitation, which is the budget constraint. For the ammonia and carbon dioxide sensor, I have used the air quality sensor as the replacement of the Bose sensor, because the Bose sensor can cost me higher, as the MQ135 is also similarity function with the ammonia and carbon dioxide sensor. And finally, as a conclusion for my prototype, I managed to reduce the level of carbon dioxide and ammonia while doing comparison. The mission was accomplished after developing a low-cost fan system using Arduino Uno as a platform to tackle this order problem. At the end of this experiment, I have gained much better about the odor elimination in the restroom, and I have known how much important is the odor elimination need to be applied in the restroom, as the unwanted gas can affect the human health as well. And that's all from me. Thank you for listening. Thank you.